the notes already written out, so I'm just going to go through problem by problem and explain what's going on there. So first we need to refresh our memory about domain and range. So domain deals with our x values. Remember, it's our input of our function, and range is our y values, or dealing with our output. So if we look at example 1, it says find the domain and range of the graph below. So we're going to look at this graphically. Okay, just making sure this is on. So if I'm thinking about domain, that's our x value. So I want to see, okay, my graph doesn't go any further left than that, and it doesn't go any further right than this value. So so since it's domain, I look at my x value. So my x value is -1, and it's a closed circle, so we're going to include -1. And if I look over here, that x value is 3.5, and it is a closed circle, so we're including it, so that's why the domain is -1 to 3.5. Now same with range. Range is our y value, so I don't care how far left or right it's going. I just need to say, okay, what is the highest point of my graph? So the highest point of my graph is up here, and the lowest point is down here. We typically read the lower ones first, so range is y value. So if that's my lowest point, -3 is my y value. So that's where that value came from. And if this is my highest point, +3 is the highest point. So that's where that one came from. All right, so you can pause the video, take a second, try the your turn, and see if you can get your values to match that. All right, now to the important part of our lesson today. It's the zeros of a function. And we've actually done this before, guys, whenever we found the solutions to our equations, whenever we found the x-intercepts, because another name for zeros are those solutions and those x-intercepts. When is your function equal to 0? So that's why it says the x values for which f of x is equal to 0. So graphically, where does the graph cross your x-axis? So y is 0. So for this first example, or example 2, it says find the zeros of the function f of x equals 3x squared plus x minus 0. So to find the zeros, we set the function equal to 0. For this one, since it is quadratic, we have to factor. So I said, okay, what two numbers add up to give me the middle term, which was 1, and what same two numbers when multiplied give me the product of the first and the last term, which is -30. So the two numbers that match that were 5 and 6, but I need a +1 and a -30. Excuse me, so I get a -5x and a +6. Or sorry, -5 and a +6. Remember, I use California method to factor. You can factor by whichever method is most convenient for you. So I did 3x over -5, 3x over 6, reduced each of those fractions, which then translated to the expression 3x minus 5 times the quantity x plus 2. Since we are solving this, it's set equal to 0. You set each of them equal to 0 and solve. So we found that x was equal to 5/3 and x is equal to -2. All right, so pause the video, try the next your turn. I know in class some students said this was much more difficult than the example problem, but then once they've remembered the first step on how to eliminate that radical or the square root, then this problem became very easy to them. All right, so in solving the your turn, you should get x is equal to plus or minus the square root of 10. Okay. All right, moving on to example 3, because what if we have fractions? So two things to think about here. Just like anything else, we want to find the 0. We set the whole function equal to 0. That is what I did over here. Okay, whole function's equal to 0 there. I could put 0 over 1, and if it makes more sense to cross multiply, that's fine. If not, just multiply both sides by t plus 5. But 0 times anything is still just 0. So I add 3 to both sides, divide both sides by 2. We find that t is equal to 3 over 2. Now, if we think about this more mathematically, anytime I have a fraction, the way to get 0 from a fraction is if the numerator is equal to 0. So really, anytime we have this, we can just set the numerator equal to 0. I explained over here why as well, it works out, and then just go ahead and solve it. So the next one might take you 10 seconds, but take a moment, try the your turn, check your answer, and then come back. All right, so that one was pretty quick, pretty painless. If we do 5 minus t equals 0, just add t to both sides and you get the t equals 5. So that's the value that makes it 0. So that one only has one 0 value. All right, and the last part of today, let me make sure. Yep. The last part of today is determining whether our function is increasing, decreasing, or constant. And what are the intervals as to where this function may be doing these things? Because linear equations are constantly, and I guess I shouldn't use the word constant, they're either all increasing, all decreasing, or constant. Okay, so they have a positive slope, a negative slope, or a 0 slope, or an undefined slope. However, if you think back to our parabolas, that's our U-shaped graph, so parabolas are U-shaped graph, it is decreasing on the left side there, and then increasing on the right side. Whoops. Okay, so this has two different types of slope. So looking at this first example, and this probably isn't the best one, so I'll do one of the your turns with you. But if I know in class I went over looking at this function, we typed it in, and we zoomed in as far as we could. And I know this what it looks like once it gets to here and here. It is constant there in the middle, but I promise you it is increasing ever so slowly. So for this function, it is actually, for a cubic function, increasing throughout the entire graph. So therefore, this we say is increasing from negative infinity to positive infinity. Okay? So let's take a look at something a little bit different where we have a little bit more fun with it. So the first your turn. Now, I will say, let's just do this over open intervals, meaning I don't have to worry about parentheses or brackets. However, if you ever get a piecewise function, you will need to worry about brackets or parentheses based upon what the piecewise function says. So, I did my increasing in green because that's positive slope. So increasing, hang on, let me see if I have green. Oh, I do have green. Okay. So increasing from there up to there, and then from here to there, it's all increasing. Okay. So we look at our x values here. Okay, that's what's important. X. I don't care how far down it's going because remember, we read a graph like we read a book from left to right. So it's increasing all the way from negative infinity, meaning all the way over here in negative infinity, not down here. All the way over here at negative infinity, it's coming up, 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 up to here. And that x value that corresponds is -1. So that's where this one comes from, okay? And then it's also increasing from here at +1. And then it's going to keep going on forever and ever and ever and ever and ever, all the way out here somewhere. Okay, so that's also positive infinity. And then we say, okay, but now I have this portion in the middle. The portion in the middle has a negative slope. It is decreasing. So I put decreasing, and then again we go by x value. So here's where it's starting at -1, ending at +1. All right, so take a moment, try this last your turn, and then come back and check your answers. All right, so you can see the increasing, decreasing, constant. Look at x values. Hey, I did put arrows on the ends here if you couldn't see that. So from negative infinity to 0, it is increasing. From 0 to 2, it is constant. And then from 2, and it's going to keep going on and on and on to infinity, it is decreasing. So now I just wrote all those numbers down, and then we said, okay, increasing. Infinity is always a parenthesis. So at 0, so I look here and say, okay, this right here is my first function, x equals 1. That's this one. I'm sorry, x plus 1. So that right there, it says it's not equal to 0, so that's why I put a parenthesis. My middle function of just 1, which is right here, is this one. And it says, hey, I'm including 0. and I'm including 2. So that's why these have brackets. And then finally, negative x plus 3 is this one that corresponds to that line. And it says, hey, we're not including 2. So that's why that has a parenthesis. And again, infinity always has parentheses.